Hello guys, welcome to another video of this project, the CRJ200 Autopilot prototype. We have our prototype in here. Today we are going to design the electronics for the control. So we have this electronic PCB. We already designed it, we have it already assembled, so now we need the other part that will be in charge of controlling receiving all the data from the push buttons, send the data for the LEDs to light up and light off, and read the encoders and interpret that signal. So we need to design it. So for control this prototype, as I mentioned, I will be using this Nucleo board, the STM32 Nucleo board F411, I think it's the model, yeah, F411RE. So this is the board that I will be using it. Why? Because it has like 50 pins, so instead of using any, I don't know, any GPIO expander or something like that, I would like to only program the pins directly, so that will be easier for me. Okay, so for this board, first of all, we need to, so we know that this is will be the brain of our project. So for this board it will be so simple, because in this case, for this specific PCB, we used a lot of components, a lot of resistors, capacitors. We know that we will be using encoders, LEDs, push buttons, all these connectors, but for our control board we only need the connector to put in place the STM, these three connectors, which are the buttons, LEDs and encoders connectors, and only a voltage connector, which will be getting the voltage from the STM32 to our prototype. So actually more than that we don't need it. So this will be a really simple PCB, so we won't have any problem, I hope. So for designing the PCB, we need first we will need first to do our schematic design, the placement, number 3, the layout, where we'll be doing all the routing and all that, and just in the number 4, the verify all our routes, all our pins are correctly. So we will need to follow these 4 steps. So let's go ahead. As you can see in here, I already decide which pins we will be using. The yellow color is for the LEDs, the blue color is for representing each connector. Actually, the 3 colors, all those 3 colors are representing the different connectors. So the yellow color, yellowish will be the LED connector. The blue color represents the push button connector, and the green one represents the encoder. So in that way we can recognize that. So here we have which pin we'll be using for each signal. Here are all the signals of our prototype, as output, as inputs. For as output, I refer the LEDs. Our LEDs is our outputs for this prototype. For inputs, we have 2 kinds of inputs, which are the push buttons and also the encoders. Those are digital inputs, but I put it like in a different way to make easier for me all the pin management and all that. So here I have all the pins that we'll be using, and also here we have a picture of our STM's pinout. So here is where every pin will go. So actually we need to change something for the encoders, because I want to have all my encoders in an interrupt pin, but all these pins has interrupts, but some of those are in a single line interrupt. So I need to make sure that every encoder's pin is in a different external interrupt pin. So for that I will just rearrange all these pins, and more than that, we are ready for start with our schematic design. Let's go.
I'll walk you through the schematics design for my CRJ Autopilot panel. First, I'll add the Nucleo board to our workspace. This microcontroller will handle all the inputs and outputs for the control board. In other words, it will be the brain of the Autopilot panel. Next, I'll add the 2-pin header for the power. This will supply the 3.3 volts from the STM32 to the interface board. Next, I'll add the 317-pin box connector. These are the most important components because they join the interface board with the control board. To ensure everything is connected consistently, I've copied the connectors and their net labels into this project. This way, the wiring matches perfectly between boards. I'm assigning the pins of the STM32 based on the table that I showed earlier. This table is super helpful because it keeps everything organized and ensures I'm connecting the right signal to the right pin. Finally, I'll review the schematics to make sure everything is correct. I'm double checking the net levels on the connectors, the power connections, and the GPIO assignments to avoid any mistake. And that's it for the schematic design of the control board. I got everything connected and ready to move to the next step, which is the PCB layout. Thanks for watching and stay tuned for the next part of this project.